Hello everyone, let's solve a classic, the two-sum problem. So we're given an array of integers nums and we're given an integer target and want to return the indices of two numbers such that they add up to the target. So like we can see from the example given, we're given the target 9, and when we sum the numbers on the first and second index 0 and 1, we see that they add up to 9, and we can assume that each input would have exactly one solution and we may not use the same element twice. So if we're given the target 8, for instance, we can't use 2 in 4 places and say that, oh, we found our sum. That doesn't work. We can't even use it twice, not to mention 4 times. We can't use it twice. Now let's give ourselves some room and jump right into it. So we're giving 2, 7, 11, and 15 and the target of 9. So we're going to be using a technique called the storage technique. And the storage technique is basically a technique where we store some values that we have previously visited, and on every iteration we go back to our storage that, okay, we are looking for something. Is it in our storage? Now, what are we looking for? That is yet to be discussed, but this is what the storage technique is about. You store previously iterated values in any system, an array, a set, a hash set, whatever, a dictionary, but in this case we'll be using an hash set. So let's look at what we want to do carefully. So we have a storage already initialized, and then we are iterating over the values in the array. So we have our target and we're like target minus 2. Target minus, so our target is 9, our current number in iteration is 2, and we have 7. So we look at our storage. Do we have 7 in the storage? If we have 7 in the storage, that would obviously point to us that we have found our solution, because then to mean that 7 plus 2 will be equals to 9. So we can easily just get the indices of this number if it's already stored in our storage, and then the index of the current number in our iteration. But as we can see from our illustration, 2 is the first element in our iteration, so we have nothing in the storage. So since this does not exist in the storage, we'll just go ahead and store 2 in the iteration. For if the current iteration does not satisfy whatever it is we are looking for at that point, we'll just go ahead and add the number to our iteration. Now we can go over to the next number in the iteration, which is 7. So we have 9 minus 7, which is 2. Now we check, does 2 exist in our storage? Because we know that if 2 exists, then we found a possible solution. 7 plus 2 is going to be equals to 9. So we check, does 2 exist in our iteration? And yes, 2 exists. So what do? We just return the index, because the question wants us to return the indices at which these numbers exist. So we return the indices of our current iteration and then return the indices of the number that we have stored in our storage technique. This is why I said I'll prefer to use an hash set, because an hash set or a dictionary allows us to store a key object value. So instead of just storing values in an array like 2, 7, 11, 15, we can store the item and the index at which it was found. We can store 7 and the index at which it was found. We can store 11 and the index at which it was found, and so on and so forth. So I'm just going to go over another example quickly so we can try to understand the concepts better. So again, I'm going to rearrange the number and act like we don't already know that we have a value, and I'm going to call our targets 9 again. So first we go over our iteration. We have 9 minus 2, and that is going to be 7, and we check does 7 exist in our storage. No, 7 does not exist, so we add 2 to our storage technique. Then we go over to the next value, that's 9 minus 3, and that's going to give us 6. So we check does 6 exist in our storage. 6 does not exist in our storage, so we go ahead and add 3. Then we go over to the next item, which is 5. So 9 minus 5 is going to give us 4. Does 4 exist in our storage technique? No, 4 does not exist, so we store 4. And besides, I'm storing this roughly. This is now I should store it, since we're using a hash set technique. Since we're using a hash set to store our values, it will be much more appropriate to store the values and their index. So 5 and then 2. So finally we go over to the last item in our array, and we do 9 minus 2, we have 7. Does 7 exist in our storage? 9 minus 7, not 9 minus 2. 9 minus 7, that's going to be 2. Does 2 exist in our storage? Yes, 2 exists in our storage, and we can just check at what index it exists. This is 0, and we can return the index at which our the number at which we are currently iterating exists, which is 4. So we'll just go ahead and return this as the answer. Now let's jump right into the code. Let's go ahead and initialize our storage first, and like I said, it's going to be an hash set or a dictionary as it is called in Python. So we are initializing our dictionary that is going to act as the storage, and then we are looping over the values in our array. Let's just get the difference and store. I'm just going to store the difference as target minus whatever value we currently are at in the array. That's going to give us the difference, and we're just going to check if our difference is in our array. We're going to return the index of that array, so it's going to be stored as this. And we're also going to return the current index at which we are at, because this is how it is going to be stored, right? So we have 2, 0, 7, 1. This is an instance of how it is going to be stored, right? So we just want to go ahead and return the index here, so it will be hash and the value. So it's going to give us the value of whatever key we are selecting here. So that is what we are doing here. If the difference is not currently in the hash set, then we just want to go ahead and append or add a number. Okay, I must have deleted a few things. This is what I should delete instead. Then want to go ahead and add the current number to our hash set, and the value of the key. The current number we are at is going to be the value as stated here, and then the key is going to be the index. Now the time complexity is O of n, because we are looping through all of the given inputs in our array, and the time complexity is also going to be linear, since our storage can grow as large as all of the inputs given. Let's look at our JavaScript code quickly, which is going to be the same as what we did with the Python, but different syntaxes. First, we are defining a variable, the hash set, and then we are again looping over all of the items in the array, that is the iteration, and then we are getting the difference from the target given and the number we currently are on. If the difference exists in the hash set, then we want to go ahead and return the index that we currently are at and the index of the number which we have stored in our storage previously. If this condition is not true, then we want to go ahead and add this number to our storage with its value, with its index rather, as the value of the key. I hope this was helpful. I'll see you in my next video. Thank you so much for watching.